Next up, we'd like to find the parametric and symmetric equation of a line passing through the point 2, 3, 4, and that is perpendicular to the plane 5x plus 6y minus 7z is equal to 20. So there are many ways that we can get the equation of a line. And so we are given the first option is you could have a point and a normal vector. You could have two linearly independent vectors. And lastly, you could have 3 points that are nonlinear. And so from these 3 points, you could technically derive two linearly independent vectors, and from those two linearly independent vectors, you could derive a point and its normal. So for our problem, let's start by finding our normal vector, because we want it to be perpendicular to a specific plane. And so for the plane 5x plus 6y minus 7z is equal to 20, its normal vector is just going to be these coefficients. And so it's going to be 5, 6, negative 7 is going to be our normal vector. And so, since now we have a point in our normal vector, we can just write that x, y, z is equal to the point that we have. So 2, 3, 4 plus this normal vector multiplied by a coefficient. So a constant. So 5, 6, negative 7, and we can call that constant t if we'd like. And then for our parametric equations, we're going to write down x is equal to a specific thing. So constant plus a multiple of t, y is equal to the same thing, and z is equal to the same thing. So let's start by doing that. So x will be the x component plus this x component multiplied by that constant. So 2 plus 5t. Y is going to be 3 plus 6t, and z is going to be 4 minus 7t. Okay, and then next up for our symmetric equations, we are going to simply solve for t in all of them. So you can get some function of x is equal to some function of y, which is equal to some function of z, and these are all going to be equal to t. And so in our first case of x is equal to 2 plus 5t, solve for the t so that we can get x minus 2 is equal to 5t, divide both sides by 5. And so our function of x, which is going to be equal to t2, is equal to x minus 2 over 5. So let's write that one out first. Okay, and then now we do the same thing for the parametric equation involving y. And so with y is equal to 3 plus 6t, we're going to move that right on over to get y minus 3 is equal to 6t, and then we're just going to solve for t. So our function of y, which is equal to t, will be y minus 3 over 6. And then lastly, let's look for a function of z using the parametric equation involving z. So with z is equal to 4 minus 7t, we can actually bring the 7t over and bring the z back. So we get 7t is equal to 4 minus z over 7 to get t is equal to our function of z, and that's going to be 4 minus z over 7. So 4 minus z over 7. And so for our final answer, we have our parametric equation and our symmetric equation. And those are your final answers.